Hello, everyone. My name is Skylar Gale. I will be presenting the scientific role in the VR training for surgeries. A brief overview of the items I will be talking about are the development of 3D models, self adaptive technologies, design strategies for education games, and advanced liver surgery. In this section, we'll loosely cover how the assets are created for students to interact with in the VR environment. Looking at the slide, you will see a simplified process on how the assets are built. For this breakdown to be quickly digestible, it is prudent to break this into three categories: data acquisition, photogrammetry processing, VR integration and development. For the 2D imaging, typically a positron emission tomography scan, otherwise known as a PET scan, is the photo that has proven to be the best at observing and highlighting functions of organs, using a radioactive tracer that reacts to the PET scan. The photo is then taken to step 2, which would be photogrammetry, which in short is a scientific method applied to obtain reliable photo information on physical objects. The photos typically provide enough information to convert them into a baseline of 3D image using various software like the ones listed on the slide, one in particular being Reality Capture. Finally, the 3D models are integrated into the VR environment and further developed using current popular VR game development engines like Unity or Unreal Engine. In this portion, the dev will add the model elements like dissection, flow data for bleeding, and animation for things like cutting and revealing the underlying structure. Parameters that may affect this would be the user interface or user experience, to include the limitations or the design of the VR hardware, like the controllers used to interact with the models and organs or structures. This topic spans into computer programming and creating a learning algorithm that tailors the course curriculum to each student, and this will increase the learning efficiency. The overarching principle for adaptive systems is to introduce a control loop that changes upon feedback provided in a closed loop system. Machine learning applies this using four categories: prediction, recognition, detection, and closed loop optimization, with each loop being analyzed and changing based on the context of the environment. In this context, the environment is a VR training system that will assess the trainee based on the program task. With various factors or modules, the modules or factors can be programmed, for example, for accuracy, time allotted/time taken, or an order of effect taken by the trainee that can be graded. Another avenue that is also highlighted is the head-mounted displays, which have been helpful in the training environment for both surgical training and rehabilitation for patients. It has been highlighted that the displays using stereographic displays have been more efficient for those suffering from sight loss or vision loss. And the overarching meaning for stereographic displays is one display per eye, as opposed to a single monitor display for a head-mounted unit. Another caveat that has been pivotal in adaptive learning has been haptic feedback. A large variety of haptic force types can be fabricated, including torque, vibration, and resistance. This feedback is used to simulate tools to be used during surgery and even provide realistic feedback of surfaces such as bone or cutting through fascia. Embodied cognition sounds very confusing, but as I read the breakdown of what it is, I surmised that to this statement, or turn of phrase: it's being thrown to the wolves, or a familiar memory of being pushed into the pool to learn how to swim. This is great for surgery training as it segues to earlier application of principles and techniques taught so that the student can attempt to master them at an earlier stage. And the resources are abundant as they no longer need to rely on cadavers and assets, which are now virtual. Somatosensory devices play an important role as these will most likely come in the form of a tool to be used during the procedure or trainee's controller. These devices have been programmed to not only provide specific haptic feedback, but will also incorporate things like temperature changing dynamics to immerse the training in the VR environment. This loops back to the aforementioned embodied cognition. My final slide. I chose this topic as it delineates a very specific training for less invasive procedures. For reference, the medical industry has shifted to developing techniques for laparoscopy to reduce the need for large surgical incisions that increase risk factors like bleeding during the surgery, and for the rehabilitation for the patient. 3D planning is a new facet that allows the trainee or even the surgeon to prepare for the order of operation in the surgery, also enhancing their spatial understanding. This is important as the surgeon is using tools to expand the surgical area, also the cavity of the patient, or relying on a camera system to lead to the site requiring action. A positive benefit to expanding these services to more surgical centers is it allows the patient to basically have a one-stop shop. They undergo the PET scan, have their scanned liver functions uploaded to a 3D model using a process stated earlier, and the surgeon can then practice using that specific patient's virtual body. This would ultimately reduce the errors during the procedure. This training will aid in the psychomotor skill sets of those who utilize the VR environment. Due to the nature of the laparoscopic surgery, your eyes are usually the camera system that has been placed in the cavity of the patient. This changes the axis in which the trainee or surgeon navigates their tools. They must learn their bearing and evolve their understanding of the spatial clearance of those tools to prevent the need for interventive procedures. This concludes my presentation on VR training for surgery. Again, my name is Skylar Gale. I hope you learned a lot about the development of 3D models, self-adapted technologies, design strategies for education games, and the advanced liver surgery. I appreciate you taking the time to listen to my presentation.